Hello, my name is Tim Harrigan. Today I will present Module 4 of the Appropriate Scale Mechanization for Smallholder Farmers online course on crop planting. The learning objectives for this unit are to understand the fundamentals of tillage and seedbed preparation, seed germination and emergence, seed singulation and delivery, plate, air, and vacuum planters, planter components such as row cleaners, furrow openers, and so on, seed covering devices and press wheels, and broadcast seeding and seed drills. A discussion of planting should accompany a discussion of seedbed preparation. Farmers till the soil for many reasons. The right type of tillage at the right time with the right implement can improve production. Shallow tillage will kill small weeds and weeds that have germinated but have not yet emerged while conserving soil moisture. Large weeds require aggressive tillage. Tillage can facilitate planter operation. Excessive crop residue interferes with the operation of the planter. For maximum benefit, mix manure, fertilizer, and soil amendments into the soil. Soil compaction inhibits root growth and limits plant water and nutrient uptake. The surface must be smooth enough that the planter consistently places the seed at the correct depth. Cropped soils are usually less fertile and productive than undisturbed soils unless they have been very well managed. While tillage can control weeds and loosen the soil to enable planting, intensive tillage with the mold-borne plow has degraded soils rather than improved soil quality and health. In some cases, mold-borne plowing with immediate planting may be suitable, but inversion tillage increases the chance of soil erosion from wind and water. Intensive tillage accelerates soil carbon and organic matter loss and degrades soil aggregation. The best soil management is the least amount of tillage needed to grow the crop. A good practice is to reduce the tillage frequency and intensity. Conservation tillage implements replace the mold-borne plow and retain protective crop residue on the soil surface. Strip tillage prepares a well-aerated zone for water infiltration, seed germination, and crop growth in a band of soil 15 to 20 centimeters wide. Most land preparation and planting for smallholder farmers in Africa is either by hand or animal power. Mechanized power is used in regions where tractors and equipment can pay for themselves. Agriculture will continue to depend for many years on human and animal power. Mechanized power will emerge where it can, where conditions are supportive. Significant improvements in production and farm profitability will emerge from improvements in small farm implements and machines such as planters and weeders. These capital investments are significant but within the reach of smallholder farmers. Such investments improve farm profitability and lead to a stronger farm economy and capital creation for larger investments. For seed germination to occur, the seed must be viable, alive, and able to germinate immediately. Some seeds may be alive but dormant, unable to germinate until an environmental stimulus, such as light, or temperature overcomes dormancy. The seed must be in a favorable environment. A correct range of temperatures is critical. Temperature affects the water absorption rate, oxygen intake, and essential biochemical reactions that affect germination. Moisture softens the seed coat and makes it permeable to water. Light can stimulate or inhibit germination of some plants, and oxygen is essential for respiration and oxygen exchange. Some crops need thinning or removal of excess plants for crop development when plants are too close together. The too close plants compete for nutrients, water, and sunlight. These plants often become stunted, and grain yield is depressed. Seed singulation measures how well a planter or seeder drops one seed at a time. The picture on the right shows maize seed dropped in an open furrow with a plate planter we developed in Burkina Faso. 100% singulation indicates all seeds dropped where intended. But we often see skips where a seed fails to drop, leaving a gap between plants. Or we may see doubles where two or more seeds drop where only one should be. One way to measure planter performance is to measure the percent seed singulation. For example, if the desired seed spacing is 20 centimeters, measure a 20-meter length of row. There should be 100 seeds dropped in 20 meters. Measure the distance between the seeds. If there are 3 gaps or skips where a seed did not drop and 2 doubles, places where 2 seeds may lay next to each other, the percent singulation is 100%, minus 3% skips, minus 2% doubles, equals 95% singulation. Even older planters should achieve 90% or more singulation if the seed and seed plate is a good match. Modern planters will be much better yet. These are pictures of the Tiller's ASMC maize planter we trained local blacksmiths to build in Burkina Faso. The seed plate in the seed box has 12 holes. The holes pick up one seed and drop the seed through a drop tube to the seed furrow below the seed box. The ground wheels drive the seed plate, and the seed plate makes one revolution every 2.4 meters. The seed plate delivers one seed every 20 centimeters in the distance the planter travels with one revolution of the seed plate. To reduce the plant spacing and increase the seed drop rate and plant population, increase the number of holes in the seed plate. To increase the plant spacing and decrease the population, decrease the number of holes in the seed plate. For example, if the desired seed spacing is 60 centimeters with this planter, use a seed plate with 4 holes to drop 4 seeds with each revolution of the seed plate. The size and shape of maize seed varies with the variety, environmental conditions, the location where grown on the ear, and other factors. Small round seeds originate from the tip of the ear. Flat seeds come from the middle part of the ear, and large round seeds originate at the base of the ear. A planter can better singulate and deliver seeds when adjusted for seed size. If the size of the holes in the seed plate are not a good match for the size of the seed, planters can deliver excess numbers of doubles where the holes are too large for the seed size, or skips where the seed is not delivered because the seed is too large for the hole in the seed plate. Planter performance improved when we screened the seed for a uniform seed size in Burkina Faso. Many modern air seeders singulate seeds below the seed tank. Fans blow seeds to a rotating meter, and the airstream carries the seed and fertilizer to each planter unit for placement in the ground. Air seeders can handle bulk quantities of seeds for planting large areas. Vacuum planters have individual row unit seed boxes. Each row has a vacuum seed meter. The vacuum draws the seed into the meter and holds the seed to the seed plate. Gravity carries the seed to the seed furrow. Vacuum planters provide good seed singulation and accurate seed spacing over various sizes and shapes. This avoids the need for sized seeds, which are often needed with plate planters. Seeding depth affects the length of time it takes for a plant to emerge and the percentage of seed germination. The long-time experience of local farmers is often the best starting point for planting depth in average conditions. The shallow planted seed will emerge sooner than deeper planted seeds, but shallow planted seeds are subject to wider swings in temperature and moisture that could increase seed mortality in dry soil. The seed must be in contact with moist soil to germinate and emerge. A large seed, such as maize, may be in moist soil at 5 centimeters in average conditions. Placing the seed as deep as 7½ to 10 centimeters in dry conditions may be necessary for adequate moisture. Small seeds are often planted shallower than large seeds. For example, an average planting depth for maize is 5 centimeters, yet small millet seeds are at 1 to 2 centimeters. Row cleaners are often used on modern planters in strip till or low disturbance tillage systems, although they are not essential where single or double disc furrow openers cut the residue. Mount row cleaners in front of the furrow opener and planter unit to brush large soil clods, stones, and crop residue to the side. This planter has a single star wheel row cleaner in front of each planter unit. Some row cleaners have 2 star-shaped wheels on each planter unit. The wheels are either interlocking or offset. The primary function of a row cleaning device is to remove residue and debris from the soil surface to facilitate planting, not to till a trench or a furrow. Following rain, runoff can collect and pond in the furrow, causing the soil to crust and interfere with seedling emergence. The row cleaners are too deep if they move soil and create a trench. Seed furrow openers create a groove in the soil for seed placement. Seed furrow openers work best when the opener is a good match with the soil and residue conditions. The runner-style openers work best on a prepared seed bed with little crop residue. Slot-style openers slide under the crop residue and lift it out of the seed furrow. Coulters in front of the opener cuts the residue and prevents residue from wrapping around the opener. Single and double disc openers cut crop residue and penetrate the soil without a leading coulter. Heavy and uneven residue usually requires coulters before the double disc openers to manage the residue. The hoe-type opener is best on rocky or rough ground. The hoe-type opener will clear stones and roots without breaking when coupled with a spring trip mechanism. Furrow openers open a well-defined trench at the correct depth for seed placement. Modern planters most frequently used openers are the V-trench and the double disc openers. V-trench openers use two angled discs and a set of gauge wheels to make a V-shaped planting furrow. The gauge wheels firm and mold the soil around the furrow cut by the discs. Disc openers are popular in minimum tillage systems with some crop residue on the surface, where they cut through the crop residue and maintain a uniform planting depth. We modified the runner opener on the right to plant behind an inline ripper with little soil disturbance. The shape is similar to a boat hull, V-shaped at the front and wider at the rear to roll soil away and prevent soil from falling into the furrow before the seed is placed. The arrows indicate the drop path for the seed from the seed box into the seed furrow. The sides of the bottom of the furrow opener are closed to firm the soil and prevent plugging the opener when set down in sticky or wet soil. Good seed-to-soil contact is crucial for seed germination and seedling emergence. Seed covering mechanisms and press wheels should 1. Cover the seed with soil, but not crop residue. 2. Firm the soil around the seed, but avoid excessive compaction. And 3. Leave a soil surface that is not susceptible to crusting after planting. Seed covering devices include discs, angled wheels, and knives. A knife cover may drag and plug up in heavy residue. A disc cover can either cut or roll over residue, reducing plugging problems. Some planters use a narrow vertical press wheel in front of the covering device to press the seed into the bottom of the furrow. Other planters use angled closing wheels to close the seed furrow and firm the soil around the seed. These photos show the shovel-style furrow closers traditionally used on planters in Burkina Faso. These closers worked best in clean-tilled fields with little residue. They would drag residue in our reduced tillage conditions, so we rejected this style as ineffective in minimum tillage systems. We replaced the shovels with small concave disc closers to roll over residue rather than drag it along. These images show examples of commercially available furrow closers. Standard closing wheels close the furrow and firm the soil around the seed. When the soil is too moist at planting, the furrow opener may smear and compact the soil on the sides of the furrow. When the smeared soil dries, it can form a barrier of compacted soil that inhibits root penetration and emergence. Closing wheels with teeth fracture the furrow sidewall and minimize sidewall compaction. Sandy soils are less susceptible to furrow sidewall smearing than soils with higher clay content. Some planters use angled closing wheels to close the seed furrow and firm the soil around the seed. On the right is a close-up of the small concave disc closers on the animal-drawn planter that we trained local artisans to build in Burkina Faso. The disc-type covers either cut through the surface residue or rolled over it. They were effective in rough and trashy conditions. This closer style is often needed in low disturbance tillage systems to gather enough loose soil to cover the seed. Covering devices assist in adequate soil cover and seed-to-soil contact. Angled knife coverers are inexpensive and work well by dragging soil into the seed furrow in conventionally prepared seed beds with no crop residue on the surface. These can drag crop residue, so they are only used in residue-free fields. Chain coverers are most effective in prepared seed beds with little surface residue. The chain is attached behind the furrow closer. Drag chains create an irregular surface over the row that helps prevent soil crusting in some soils. Press wheels have three main purposes. Press wheels follow the furrow closing device and facilitate soil movement into the seed furrow to cover the seed with the correct soil depth. Press wheels firm the soil at seed depth to create good seed-to-soil contact and firm the soil over the seed to minimize soil moisture loss. Press wheels create soil conditions over the seed to minimize soil crusting following rain. The press wheel on the left is a traditional concave design for animal-drawn and push planters in Burkina Faso. The concave shape firms soil from the top and sides and avoids leaving a flat surface susceptible to ponding in an intensively prepared seedbed. We redesigned the planter for performance in lightly tilled ground with surface residue. The new press wheel is heavier and slightly convex, applying more soil firming in a narrow band over the seed. It worked well in the sandy loam soil with soil clods and voids to minimize crusting. The press wheel on this sugar beet planter is rubber and will flex to shed sticky soil that may build up in moist soil. The concave shape firms the seed from the side and the top of the furrow. The press wheel leaves an irregular surface contour, irregular soil firming, and small clods. An irregular surface above the seed will create planes of weakness and minimize soil crusting. Following a hard rain, the soil will dry unevenly in areas with clods, an irregular surface contour, or variable levels of soil firming. Emerging plants can push through soil cracks or weak areas in the crust. Avoid press wheels that leave the soil flat and smooth with no surface clods. On this planter, the seed depth adjustment lever is above the planter's furrow closers and gauge wheels. You will adjust the degree of soil firming by the press wheels with the lever above the press wheels. You may see animal-drawn planters like this Tiller's ASMC planter we redesigned with farmers in Burkina Faso. This planter has several important modifications to improve performance in minimally tilled and residue-covered fields. We trained local blacksmiths using locally available materials to build a low-cost seed plate dry mechanism and improve the seed plate and delivery. We developed a furrow opener shaped like a boat hull with a closed bottom to create an excellent seed furrow with uniform depth control. We built offset, concave furrow closers to roll over rather than drag crop residue, and a heavier convex press wheel for better seed-to-soil contact in low disturbance, soil stabilizing, zone tillage, and cloddy, minimally tilled soil. Also, we extended the chassis frame to improve residue flow and reduce plugging. The height of the handle is adjustable to improve operator comfort. We reduced the cost of the planter by 30% while greatly improving performance. Farmers widely rejected planters introduced in West Africa decades ago because of their high cost and poor performance. The planter we developed in Burkina Faso solved the problems with that old planter. The new planter's mechanical advantage enhanced the maize crop's biological efficiency. Compared to hand planting, seeds were placed at a uniform depth and constant spacing. Seeds germinated faster and emerged at a consistent rate. Side-by-side grain yield comparisons in farmer fields revealed a grain yield advantage from machine planting ranging from 50% to 150% compared to hand planting. Much of the yield increase was due to reduced seed loss to birds. Birds can easily find and steal hand-planted seeds, but cannot steal machine-planted seeds because they cannot find them. This field is being intensively tilled before seeding a sugar beet crop. Sugar beet seed is small with a 19 to 25 millimeter seeding depth. Many growers prefer intensive tillage to provide small soil particles for good seed-to-soil contact, and there is some concern about disease carryover on crop residue. The consequence of such intensive tillage is soil crusting from rainfall, preventing seedling emergence and occasional replanting because of poor stands. Strip-till planting refers to planting into prepared strips of tilled soil. Strip tillage has the advantage of a tilled seedbed in the planting zone, but retains crop residue between the rows to prevent wind and water erosion. It also avoids the need to till the full width of the field, saving time and energy. The tilled strips are prepared in a separate operation before planting. The seedbed tillage unit has a ripper shank, 2 wavy coulters, and a trailing rolling basket to level and firm the seedbed. The machine in the upper left photo creates the tilled zones while applying and incorporating fertilizer in the tilled zone. Then, the planter follows seeding maize in the tilled soil. In Burkina Faso, we trained the local artisans to build an inline ripper with a ripper shank and a rolling harrow to level and firm the seedbed. We captured the soil conservation benefits of strip tillage with an affordable mechanization level for local farmers. Women report that planting is one of their most difficult tasks. Maize is typically hand-planted by women and young girls using a daba, a short-handled hoe, placing 2 seeds every 40 centimeters. This spacing represents a comfortable action with the hoe and a small step between seed pockets. 2 seeds per pocket assure the successful germination of at least one plant, resulting in few skips within the row. Seed loss to birds was a significant problem here and a frequent reason for the need to replant. These hand seeders allow the operator to stand when planting. The planters place 1 seed per hole. This style eliminates the need to bend over and thereby reduces some of the difficulty for the workers. This jab planter has two hoppers, one for seed and the other for fertilizer. Push the jab planter into the soil to the desired depth of seed placement. Squeeze the handles together and the seed drops into the seed pocket. The farmer's responsibility is to determine the spacing between the seeds. The seed is released separately from the fertilizer, and the seed and fertilizer do not come into contact. Push planters meter and drop seeds in a furrow created by the furrow opener. This style of seeder is for a tilled seedbed with little crop surface residue. The ground drive wheels drive a seed metering device. Seed metering on older style push seeders consists of an auger and a trip gate. When the gate trips, multiple seeds drop into the furrow. Thinning to reduce the number of plants in a group is often needed for most crops. Broadcast seeding refers to scattering the seeds on the soil surface. Broadcast seed by hand or metered from a hopper through a variable opening onto a spinning disc that throws it horizontally. Sometimes a fluted wheel meters the seed. The width of coverage depends on the seed size, shape, and density. Broadcast seeders cover a large area in a short time. A shallow tillage pass to cover the seed is often needed. The ASMC team is evaluating the utility of a small two-wheel drive tractor and various attachments for smallholder farmers in Senegal. The image on the left shows a Danish tine harrow tilling a seedbed in the previously tilled ground. A locally built two-row adaptation of the Senegalese Super Eco planter seeding maize is on the right. The two-wheel tractor has adequate power for seedbed tillage, row cultivation, and planting. Additional testing is ongoing. Seed drills drop seeds into narrow rows, typically 15 to 20 centimeter row spacing. A ground-driven auger with a variable width seed gate controls the seeding rate. The seeding rate is measured in kilograms rather than seeds per hectare because drills do not singulate seeds. The image on the top left shows a two-wheel tractor drawn 7-row drill seeding a small grain. The bottom left is a close-up view of a no-till drill. A double-disc furrow opener loosens the soil and drops a small amount of fertilizer into the furrow. Seed, usually a small grain or forage crop, drops on the soil surface in front of the vertical press wheel. The top right image is of a seed drill for conventional tillage hitched to a coulter cart in a no-till seeding. Conventional seed drills are not heavy enough to penetrate the soil in no-till conditions. The coulter cart uses coulters to till a narrow band of soil in front of seed drill furrow openers. The photo on the bottom right is a spring tine harrow following the press wheels in a no-till seeding. The harrow distributes crop residue and helps cover the seed with loose soil. Cropped soils are usually less fertile than undisturbed soils. While tillage can control weeds and loosen the soil for planting, frequent moldboard plowing has degraded soils rather than improved soil quality and health. Significant improvements in production and farm profitability will emerge from improvements in small farm implements and machines such as planters and weeders, where capital investments are within reach of smallholder farmers. For seed germination to occur, the seed must be viable, alive and able to germinate immediately. A correct range of temperatures is critical. Temperature affects the water absorption rate, oxygen intake, and essential biochemical reactions that affect germination. Seed singulation measures how well a planter or seeder drops one seed at a time. 100% singulation indicates all seeds dropped where intended. A plate planter can better singulate and deliver seeds when adjusted for seed size. If the size of the holes in the seed plate is not a good match for the size of the seed, planters can deliver excessive numbers of doubles or skips. The shallow planted seed will emerge sooner than deeper planted seeds, but shallow planted seeds are subject to wider swings in temperature and moisture that could increase seed mortality in dry soil. The primary function of a row cleaning device is to remove residue and debris from the soil surface to facilitate planting, not to till a trench or a furrow. Seed covering mechanisms and press wheels should 1. Cover the seed with soil but not crop residue, 2. Firm the soil around the seed but avoid excessive compaction, and 3. Leave a soil surface that is not susceptible to crusting after planting. Seed furrow openers create a groove in the soil for seed placement. Seed furrow openers work best when the opener is a good match with the soil and residue conditions. Drag chains create an irregular surface over the row that helps prevent soil crusting in some soils. Chain coverers are the most effective in prepared seed beds with little surface residue. Avoid press wheels that leave the soil flat and smooth with no surface clods. An irregular surface above the seed creates planes of weakness and minimize soil crusting. Emerging plants can push through soil cracks or weak areas in the crust. Strip till planting refers to planting into prepared strips of tilled soil. Strip tillage has the advantage of a tilled seed bed in the planting zone, but retains crop residue between the rows to prevent wind and water erosion. Broadcast seeders cover a large area in a short time. A shallow tillage pass to cover the seed with soil is often needed.